welcome. This evening I want to take you through this question. The standard electrode potential for the elements A, B, C, and D given below. You see them to answer the questions that follow. The letters do not represent the actual symbols of elements. So we have this element. You can see the electrode potential is standard electrode or standard electrode potential. For A has negative 0.76, as you can see all of that. Now I want to take you straight to the question so that I can be able to answer this question. Which element is the strongest oxidizing agent? Now that's where I will start to explain something. Strongest oxidizing agent, the most positive is the strongest oxidizing agent. So you just check the standard electrode potential. The one you see having the highest positive, that one is what we call the strongest oxidizing agent. Therefore, in our case, our oxidizing agent is this one. This one is our strongest oxidizing agent. Therefore, how are you going to write? You are going to give this one as element what? D4, because we are going to use this one, the one in aqueous, we give it D4. You can also give D3 positive, because in this case they gave it in forms of the ion. Therefore, the most positive, or if you are confused with this, you can even give the, but they are asking which element. So you give DH. If it is a solid, you give it as a solid. But they have given in aqueous, so you will give it as an aqueous. So the most important thing is to know that the strongest oxidizing agent is the element with the highest positive. The most positive is the strongest oxidizing agent. So if I compare C and D, which one is a stronger oxidizing agent? This one is a stronger oxidizing agent than a C, because it is more positive. Next question is which element is the strongest reducing agent? Strongest reducing agent is the one that has the highest negative. That's what you consider. The highest negative is the strongest reducing agent. As the strongest reducing agent will always give electrons. It will give electrons and it will undergo oxidation. An element which gives electrons or which donates electrons undergoes oxidation. The one that receives electrons undergoes reduction. So the strongest reducing agent here, our strongest reducing agent is element A. As you can see, the most negative. The one that has the highest negative is the strongest reducing agent. The next question is that draw a well-labeled diagram of an electrochemical cell that would be obtained when a half cells of element A and B are obtained. So B and A, we have this one, the one that has negatives. So negative 0.76 and 0.44. So I have, because to save time. So this is what I have drawn. So I want to explain what I have done. This is electrode A. This one is electrode A. And this is electrode B. I have used electrode B on the right side. The solution you are using, the electrolyte, must contain the ions of the electrode. Now this one you can see this is B, therefore the electrode is B, the electrolyte must contain the ions of B, as you can see. So that's what you must do. It must contain the ions of B. Like they say, similar that, and then 1 molar. It is this, you remember the standard condition of the electrolyte, they should be 1 molar. So you should write 1 molar of this solution. This solution should be 1 molar and nothing else. And then you should always remember to use the salt bridge. You should remember to include the salt bridge. And then the next thing is this one, the voltmeter. You can use the voltmeter or the bulb, but it's okay, you use the voltmeter. I have explained that. So the next question maybe you will be asked is to show the electrons flow. Where will electrons flow from to where? You must know that electrons flows from the metal that is more reactive. A more reactive metal, electrons flow from an element that is more reactive to the one that is less reactive. So in this case, electrons will flow from where to where? Let me finish this. So let us check which element between A and B, which one is going to give electrons, which the element that gives electrons undergoes oxidation. And you should know that the element that is the most negative, you compare between the two metals you have, that are the two half cells, which one has the electrode standard that is more negative? The one that is more negative is the one that will give electrons. Therefore, A will give electrons. So if A is giving electrons, it means that it is more reactive than B. So B will not give electrons. Instead, it will receive because it is less reactive compared to A. So A is a stronger reducing agent than B, right? But if I compare B and C, B is a more reducing agent than C. You should know. Suppose I gave you the C and the D. Which one is a reducing agent between this? Let me show you this one. P1. If I give you this, which one is a more reducing agent between C and D? A more reducing agent. You should consider, always remember that the most positive is a strong oxidizing agent. So the one that is more positive will receive electrons. The one that is less positive will give electrons. That is something you must always remember. So we were talking about this here. So meaning that A is more reactive, therefore electrons will flow from going from A to B, this direction. The electrons will flow this direction. So electrons will flow from A to B because A is more reactive than B. The next question is calculate the EMF or the E value of electrochemical cell constructed when B, this one is connected. When B and the A is connected, the two are half cells. What will be the, so I have given this here. The EMF is equal, you should know this formula, that the EMF is equal to E standard of reduction minus E standard of oxidation. So it means that you must know which element that is undergoing oxidation and which one is undergoing reduction. That's something you must know. Therefore here, you go back A and B, which one is undergoing oxidation? Oxidation is A because it is more reactive, it has the more negative, it is the most reducing agent. A most reducing agent will provide electrons, will give electrons. Therefore, A will undergo oxidation. Once you have known that, it is obvious that the other one will undergo reduction. Therefore, 0, negative 0.4 minus according to the formula, and then open bracket because the other one is negative. So you write like that, and then the answer will be that one. You just now, this one, a negative times a negative will be a plus, and a negative 0.44 plus this one will give you positive. This one must be a positive, 0.32 volts. Which two elements, if used together in a cell, would produce the largest EMF? The element that will produce the largest EMF, one that is the most negative and the most positive. I've said that the elements that will give the most the highest EMF is the most negative and the most positive. So if we connect D, element D and element A, it will give us the highest EMF. Therefore, you should know that. You should know that D, this cell, and the other cell, I said A, will give the highest standard electrode potential. So what I have said, the concept is that the most positive and the most negative, when they are combined, they will give you the highest EMF, the largest electromotive force.
So let us question. In an electrolysis, a current of 200 amperes was passed through a molten oxide of metal Q for 58 minutes, and 64.8 grams of the metal deposited. Determine the charge on the metal. 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 So first, we know how to calculate the quantity of electricity. Quantity of electricity is equal to current times time. This time must be in seconds. Time must always be in seconds. But as you can see, our time given in what? In minutes. So you must multiply times 60 to make it so. We have multiplied here times 60 to ensure that we have changed the time into seconds. So time, it is time T times current I. So therefore current is 200, time is 58. We have multiplied by 60 to convert to seconds, to convert this minutes to seconds. Therefore, when you multiply this one, it will give you 696,000 coulombs. The SI unit of quantity is coulombs. But we were given that the metal that was deposited, the mass is 64.8. It means that these coulombs here, this quantity of electricity produced 64.8 grams. So these grams produced this kind of quantity. We will ask, what will the RAM of the Q? Because in here, down here, you will be given the RAM. Must be given that. I think that the question is gone somewhere. Q, you must be given that Q equal to 27. EQ is 27. If Q, it means the RM of Q is 27. So if this will give you this, what about 27 grams? 27 grams will give us this coulombs. It will give us that coulombs. 27 will give us 290,000 coulombs. But we know that 1 Faraday equal to 996,500. This one is always given in a bracket. That it was given here, but this question I don't know where it is here also. But 1 Faraday here is equal to 96,500 coulombs. That one you was given. If 1 Faraday is equal to this, we want to find out how many Faradays are there in 290. So we find that there are 3 Faradays, and therefore that is the charge of the metal Q. That's how you calculate the charge from the quantity of electricity. I want to take you very fast another question. During purification of copper by electrolysis, 1.48 grams of copper were deposited. When a current was passed through aqueous copper 2 sulfate for 2.5 hours, calculate the amount of current. Now here you are required to calculate the current. We don't have current, but we know our metal is copper. Copper has how many Faradays? It has 2 Faradays. How do you know? The charge of the metal is the Faraday, is 1 Faraday. If it is sodium, it has 1 Faraday. Copper, the charge of copper is 2. The valence actually. The valence of copper is 2, therefore it has 2 Faradays. So first we know that 1 Faraday is 96,500 coulombs. So we will ask, what about 2 coulombs? What about 2 Faradays? So 2 Faraday will give us 193,000 coulombs. That's what it will give us. But we know that 1 mole of copper ion, or 1 mole of copper is, we have been given the RFM, which is 63.5. 63.5 is 1 mole of copper. Therefore, 1 mole, which is 63.5 grams of copper, has these coulombs, 193 coulombs. So we will ask this amount
the mass that was deposited, what could it contain? What does it contain? How many coulombs does it? The quantity of heat that was produced or that was used to produce this? What is that quantity of heat? So we will ask 1.4 grams will be what? So when you cross multiply, you realize that it will give us 4,498.2678 coulombs. Now, since we have the coulombs, we know the formula of calculating the current, the quantity of electricity. Quantity of electricity, Q equal to current times time. But we have the quantity of electricity now. We have the quantity of electricity, but we don't have current. But we have time. Time, it was 2.5. 2.5 is the same as 2.5 hours. So you must convert these hours to minutes and then to seconds. How do you do that? You know that 1 hour is equal to 3,600 seconds. So you just multiply with 300 and you are done. Because you convert the 3,600 is 60 times 60. You convert this to seconds by the multiplication of that. So we have 900 I, and if you divide by that, you will find that our I is, that is current is 0.5. Our current is 0.5 amperes.
Next one, let us go to question, which is organic chem. So where do you begin at such a kind of question? Where do you begin? It is important. I hope you have read, you know these things. Now you will be able to know that this here is a double bond. If it is a double bond, sometimes if this equal sign is not there, they can remove it like that. So you are supposed to know that this one, how do you know? You must know that this one is an alkene. So it is important for you to know that. It is important for you to know that. But to make things easy for you, the double bond is always there. So this one is an alkene. And how many carbons are there? There are 1, 2, 3. So that one is propene. So you should know that. Now we have this. So we have the arrow from propene going up. There is this arrow going up. There is this arrow going up. So we are going from propene to J. What is happening? Step 1. Step 1, you can see step 1. We are adding hydrogen in the presence of the nickel catalyst. That one is obviously hydrogenation. So I hope you should know that once you have seen that, you should know that that is hydrogenation, addition of hydrogen. So when you add hydrogen to an alkene, you form an alkane. Therefore, definitely J is an alkane. And what is the name of that alkane? From here, alkene, this is propene. So we are going to have propane. So J is propane. And you should know how to write those equations. Now from J, we are going to where? We are going to step 2, this direction. So here, we can see chlorine here. We can see chlorine. So we are adding chlorine. You can see that this is chlorine we are adding. And remember, this is an alkane. Alkanes are saturated. Alkanes are what? Saturated. So if they are saturated, it means they don't undergo other reactions other than substitution. So this reaction in step 3 is a substitution reaction. The conditions required for substitution reaction is the presence of the UV light. UV light is required for substitution to occur. Now from propene, when we go to this direction, we are adding bromine. So bromine you have been given here. So sometimes you cannot be, so when you are told bromine, you should know bromine is Br2. So we are forming a substance M. So bromine, when you add bromine to propene, the double bond breaks and it is going to form 1,
1,2-dibromopropane. 1,2-dibromopropane. Now let us go down. From propane downwards, step V, we can see this is a polymer. This one is a polymer. Therefore, step V, it is polymerization, right? But it is not just a polymerization, but it is called addition polymerization. So we are forming a polymer. What is the name of this polymer? You should know that we are coming from propene. Therefore, this one is called polypropene. Polypropene. Now, I hope we have finished talking about this side. Let us go to this. There is from here step 3. So step 3 is coming from here, this direction. Step 3 is coming from here, from ethanol. No, is it ethanol? No. Why is it? It is not going to be ethanol because it is how many carbons? 1, 2, 3. Therefore, it is propanol. Right? It is propanol. You count the number of carbon atoms, and you see this is what? This is OH. So OH, it stands for an alcohol. So an alcohol, it is from this alcohol we obtained propene. Which process is that? So removing of water from ethanol to form propene, the process is dehydration. Removing of water is called dehydration. What are the conditions necessary for dehydration? You should know that we must have concentrated sulfuric acid, sulfuric 6 acid, and the temperature of 60, and the temperature of 160 to 180 for that process to occur. Now let us go from propanol down, this arrow, from propanol down. From propanol down here, we are having T and gas P. So what has happened? We are adding sodium. We are adding sodium metal. When sodium reacts with an alcohol, we form an organic salt plus hydrogen gas. Therefore, gas B is hydrogen gas. And then T, it is sodium 1,2,3 propoxide. This one is going to form sodium propoxide. Therefore, T is sodium propoxide. Sodium propoxide. If it is ethanol, we form sodium ethoxide. If it is pentanol, we form sodium pentoxide. So that's how we use that. Now let us go upwards. From propanol up, it undergoes a certain process and water is formed. That is obviously combustion, burning. When ethanol, an organic compound, is burnt, we form water and carbon 4 oxide. So L is actually carbon 4 oxide. So we form carbon 4 oxide, which is L, carbon 4 oxide. Now we have remained with this coming down here. This is they forgot to write the step. Could it be step 7, all of that? So we are forming Q, and we are adding what? We are adding acidified potassium dichromate. Acidified potassium dichromate is what? Is an oxidizing agent. So propanol is undergoing oxidation to form Q. So oxidation, remember, is an addition of oxygen. Therefore, propanol will added. If you add oxygen here, you form propanoic acid. So Q is actually a propanoic acid. Q is called propanoic acid. Propanoic acid. It's called propanoic acid. What else have I not? We have not said. Yeah, so we have mentioned all those. So when you come to questions, now you realize that we have answered everything. Name substance J and draw the structure. So substance J is propane. The structure, you know, it is 3 carbons and then hydrogen, 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 like that. Reagent conditioning step 2. Reagent is concentrated sulfuric acid. We need a temperature of 160. So you should temperature of 160 to 108. That one you should know that. Step 2 is
substitution, we need UV light, still required, or sunlight. L is carbon dioxide, B is hydrogen, Q is propanoic acid, M is 1,2-dibromopropane. That's simple.
Now let us look at this question. The setup below was used to carry out electrolysis of magnesium sulfate solution using inert electrodes. So we have, you can see the setup, the diagram. So I am doing this so that we can look at the electrolyte. The electrolyte is magnesium sulfate solution. This electrolyte here is magnesium sulfate. So first you must know the ions present in that electrolyte. So here in magnesium sulfate we have magnesium ion, we have this magnesium ion, we have hydrogen ions from water, right? We have hydroxide ions from water, and then we have the sulfate ions from the sulfur, so the magnesium sulfate, right? So the hydroxide ions are negatively charged, as you can see. The sulfate ions are negatively charged. The magnesium is positively charged and the hydrogen are positively charged. So we have 2 cations and 2 anions. Now during electrolysis, what happens when the switch is switched on, or when the switch is complete, when the circuit is complete, what happens? The positively charged ions and the positively charged electrons migrate and they move towards the negative, the cathode. Now before even we go there, which one is the cathode in this diagram? So look at this one. We have been given this, the small one and the bigger one. Yes, you should know the small and the bigger one. Which one is the cathode and which one is the anode? Now the bigger, the one with the long stick is the positive. Therefore it is the cathode, the anode. The small is the cathode. When you are given that, you will be able to know that this now is this, let me draw this, this one. This one is what? Is the cathode, and this one is the anode. The one with the big one is the biggest stick stands for the anode. Now, what happens during electrolysis? The negatively charged anions migrate and move towards the anode, because the anode is positively charged and the ions here, they are negative, therefore they will move to the anode. The positively charged ions will migrate and move towards the cathode. So when they reach there, and there are 2 of them, there is one that is going to be preferentially discharged. So which one is going to be discharged at the anode and which one is going to be discharged at the cathode? I have given the electrode potential for each. This is in volts. It is in volts form. So we have given all of them in volts. Now, because this one you will be given, and you are supposed to use this information to know the electrons, the ions which are going to be discharged at which. So magnesium hydrogen ions will migrate towards the anode, this side, towards this anode. When they reach there, which one is going to be preferentially discharged? So let us look at it. So say the magnesium. So let me start from the cathode, because I like starting from the anode, where the oxidation is taking place, where where electrons are given. Therefore, I think that one is okay. So let us start at the anode. At the anode, this is the anode. So when hydroxide ions and sulfate ions reach the anode, the hydroxide ions are preferentially discharged, and the sulfate ions remain. They are not discharged. Why? So let us look at the the standard electrode potential for hydroxide ions and the sulfate ions. The sulfate ions is positive 2.01. Hydroxide ions is positive 0.4. I told you the most positive is a strong oxidizing agent, and a strong oxidizing agent is very mean. It does not give electrons. So when you compare between the EMF, the E standard, the electrode standard of hydroxide ions, and that of the sulfate ions, you realize that the sulfate ions has the highest positive here. Therefore, it is not going to give electrons. So the one that is going to be discharged, it is the hydroxide ions. Therefore, hydroxide ions are going to be discharged at the anode, giving out 4.
In the oxygen is given out and water is given out. So that's why now you see in this side here we are going to have hydrogen, oxygen here. So here it is oxygen. Here oxygen is going to be produced there. Oxygen here, oxygen O2. And this one we will see it is going to be hydrogen. The volume of hydrogen is 2 moles. That's why the gap here you can see is very big, because we have 2 moles of hydrogen produced, and the oxygen it is 1 mole. So that's why the volume of oxygen here is less and the volume of hydrogen is big, or is more. Now the magnesium ions and the hydrogen ions migrate towards the cathode here, When they reach here, let us see which one is going to be preferentially discharged. Hydrogen is 0, right? And then magnesium is negative 2.38. So magnesium is very willing to give electrons, but it doesn't want to be given electrons now in this time. So this one is a strong reducing agent. Remember, this one has already, the electrons has been given. We need to receive something that's going to receive electrons. Therefore, magnesium will not receive the electrons because it is the most real negative here, and it gives electrons. Therefore, this one will receive the electrons and it will undergo reduction. Therefore, hydrogen ions here receives the 4 electrons and we form hydrogen gas at the cathode. Sorry, this one is the cathode. At the cathode. Hydrogen is produced. So I hope I have said something that may help you. So name a suitable pair of electrode that can be used in the process here, because it is inert. We were told it is inert. Therefore, we use carbon-carbon or platinum-carbon. It is okay. State and explain the changes of concentration of magnesium sulfate solution in the process as the process proceeds. What will be the concentration? So the concentration of magnesium sulfate will increase. So the concentration of magnesium sulfate increase because the hydrogen and the oxygen given off at the electrode reduce the water content. So the water content is reduced, and therefore the concentration of the electrolyte actually is going to increase. I think that's what I wanted to share with you. Thank you.